Welcome back after the short break, and we are ready to start the next session, where we will be discussing about the issues and challenges during the implementation of the new norms by various expert speakers with me. I have Sri N.K. Singh from GIPCL, Sri Alok Kumar Sahu from Jindal Steel and Power, and Mr. Anup Bhargava has already joined me. So I will request Mr. N.K. Singh to proceed further with his presentation, please.
Good morning. At the outset, I express my sincere thanks to Mission Energy for giving us opportunity to share our views regarding these environmental norms. I have heard all the viewers and presentation yesterday and today. There has not been intensive discussion regarding the new environmental norms, different technologies available to comply with the norms, issues in implementation of conventional plants, and then regulatory requirements. I will share my experience of a new technology, that is CFBC. Though our plants are 20 years old, and because of this technological issue, CFBC technology, we are able to comply with even the new environmental norms. And for SOx and NOx, it is much below the complying requirements of new environmental norms. So let me share the presentation and then we'll have detailed discussion. I am from Gujarat Industries Power Company Limited, Surat Lignite Power Plant. I would like to have some glimpse of our company profile. Then I thought it would be better to share with the participant the CFBC technology process, because it is quite different from the conventional power plants what we are discussing. And it is not only in the process side, the environment side, which we are discussing and deliberating. There will be quite significant difference in the process and the compliance requirement, and even issues and challenges will be different than the normal conventional thermal power plant. I had been experience of working in the conventional thermal power plant. So I would like to highlight that difference, and then it would be better to understand the plant performance. I will just give a glimpse, and then I would like to have a salient features of CFBC boilers, especially relation with the SOx, NOx, and the ESP performance. And then I will like to throw light on the compliance of the new environmental norms and the major issues and challenges what we are facing with respect to compliance with the norms. Even not only the compliance, the cost part, the regulatory part, and the plant operations requirement. This company is an IPP, independent power producer, having gas in its kitty, the gas plant, thermal, lignite plant, thermal, that with CFBC technology, green and clean coal technology. Then we have the lignite mines, our own mines, you can see on the screen. And of late, we have entered in a big way in the renewable energy. Earlier in 2012, in Gujarat solar policy, we have the 5 megawatt, but now our capacity is already, we have added 162 megawatt solar, and another 100 megawatt is in advanced stage of implementation at Radhanesla in Gujarat only, in Radhanesla solar park. So it will be another 262 megawatt. Then we have different wind plants also in the Gujarat, in Kutch region, Rajkot, Amroli. So what I would like to highlight is we have the energy mix, and in portfolio already we have 25% renewable energy, and with addition of 100 megawatt we'll go to the 35% in the total energy portfolio, this renewable energy. As a company, we have this ISO, this certifications, integrated management systems. We have ISO quality, but more important, I would like to highlight we have the environment management system also. ISO 14001 2015. Apart from the safety and ISO and the energy management, I would like to highlight this company is having the first in the power sector to have energy management certification. As I told earlier, I would like to show the process side. If you see the slide, boiler is in the central, and right side of the boiler is turbine and electrical system and grid, which is just like the conventional power plant. There is no difference. In the left side, boiler itself is quite different, and you can see a glimpse in the below picture. The boiler is totally different. It is having lot of refractory work, that is around 1500 metric ton in each boiler. Apart from that, there are external heat exchangers, which is considered to be the integral part of the combustor for providing the heat area in the superheater, reheater, and evaporator coil is also there. That will come in the slides. And then there is major difference in the fuel side also. We are using lignite, but there is no pulverizers because size is minus 10 mm. And we are adding limestone with the lignite for sulfur capture. Then as we are taking dry air disposal, and it is being used for different purposes, mainly for fly ash bricks and paving block products. Below you can see the lignite, lime going to this is the combustor. The main salient, once we call this circulating fluidized bed boiler, I will explain in this why it is circulating fluidized bed boiler. And in back pass only, you see the final superheater and final reheater, where in the conventional thermal power, it is always in the main combustor. So that is the major difference. In this slide, you can see when we fire the fuel here, after combustion, it goes to the cyclone. Here it is being separated, and clean flue gas is going to the back pass, and the solid particles. Solid particle constitute the lignite, as well as we are using the bed material, which is a heat transfer medium being used in CFBC boiler. These all are recirculated and being back to the combustor. That's why we are calling it circulating fluidized bed. For fluidization, we are supplying primary air from below, and to support the combustion, we are giving secondary air. Then, once combustion takes place, the whole mass inside the combustor behaves like a fluid. That's why we call it fluidization, circulating fluidized bed. So, a fluid, there is a maximum transfer of heat is through conduction medium on the wall, and then it goes to the cyclone, and after recycled, again recycle back. This has major impact on the environmental side, on the process side, as well as the emission side. So that I will explain. That's why I would prefer to explain this. And then I will move to the next slide. See, apart from other drives, this is the new blowers are not there in the normal conventional power. Here we have almost 12 to 15 blowers. And then apart from combustor, you can see that this is the evaporators, this is superheater, this is superheater, this is reheater. And then in the previous slide, I have shown in back pass, there are superheater, reheater and economizer. And then it comes to air heater, then ESP, and then ID fan. So the difference is two things. Blowers are there, which are not in the normal conventional boiler, and then evaporator and the heat exchangers, in which we have provided superheater, reheater, and evaporator coils, that is the water valves. Before going to the environmental part, just I would like to show this. This here, Surat Lignite Power Plant has created a benchmark in CFBC technology, and not only environment side, on performance side also we have achieved around 82.9%, and normally our PLF is more than 75.9%. Combining with the old and new plants, in new plants we achieved, which were commissioned in 2010, around 80%, and the old plant 75%, considering the target availability and the fixed cost recovery. This we call environment friendly circulating fluidized bed combustion. That I will explain in the next slides. I would like to, this boiler was commissioned in the year 2000, unit 1 and 2, but boiler was supplied by BHEL, but design was done by Lurgi, Lenses and Babcock. Lurgi was a process developer, Lenses was engineering supports, and Babcock, you all know, they are the leader in the manufacturing. So they have assisted the BHEL to supply this CFBC boiler from this. Then the capacity, already it is mentioned, considering 125 megawatt unit size, 390 ton per hour. Then in phase 2, we have taken some margin considering the liquidation in the fuel. And the pressure and temperature is it is not a very high, or if you compare with the supercritical and ultra supercritical, it is 132 kg only and 540 degree. The main part I would like to highlight is this. Earlier we have designed with 24% moisture and 4,240 kilocalorie GCB of lignite. When I am talking about lignite, lignite is nothing but it is a premature version of coal. It has inherent more moisture content and the sulfur content. This 45%, then when we commissioned the new plants in 2010, we had seen that there is a degradation in the fuel, and then we have changed the GCB and moisture content also. See, from 24% to 45%, and the GCB has gone down 4,240 to 2,900. So there has been some significant design changes in the, particularly on the considering the fuel in the combustor size, rotary equipment design, ESP, and other things. And now, as on data say, now we are getting a lignite with 2,500 to 2,800 kilocalorie, with moisture variation from 48 to 52%. In this boiler also we are using HFO only for startup, and maybe during for stabilization also in case of fuel cut out. Here I would like to discuss and highlight about the salient feature of CFBC boiler, which is more on the environmental side. See, as I have shown in the previous slides, it is suitable for low-grade fuels. Fuels, what we are using is almost 2,500 to 2,800 GCB. Apart from the lower GCB, the major issue is the moisture, which is in the range of 48 to 52%. I mean to say, in total content of the fuel, 50% is moisture. So you can imagine how the difficulty would be in operation, and the heat value and the impact on the efficiency side. This boiler is environment friendly. In situ sulfur capture means in the cyclone, in the combustor and cyclone, what we have seen, more than 95% sulfur is being captured. And there is a low NOx generation. Low NOx generations are on 3 accounts, mainly on 3T, we call 3 T's, temperature, time, turbulence, which is the key for the boiler performance. Temperature here is in the range of 850 to 900 degrees centigrade. So this temperature don't support the NOx formation. So NOx is very low. Apart from this, on air side also, we supply primary air, and the for stage combustion we provide secondary air, which control the NOx for air. And then on combustion side, when we fire this lignite in the combustor, it goes to the cyclone, and unburned particle along with the bed material, which is a heating element in the combustor, comes back again to the combustor. So it recirculates inside the combustor, cyclone, unless there is a complete combustion, almost 98 to 99%, more than 98%. And then the residence time is infinite, whereas in second in the conventional thermal power plant, it supports the environmental requirement. High combustion efficiency, fuel flexibility, as already I've discussed, with lignite, different, even if I would like to highlight here, for certain percentage, we have used imported coal also, with 10%, 15% and 7% variations, considering the low grade of fuel. So that fuel, with though it was designed with the lignite, we are filing imported coal also. In fuel preparation, it is simple. Why we are saying simple? Because all the participants and are very much aware. In conventional power plants, we are using coal with grinders and mills, coal mills, what we call, and the output is 75 micron of this. So here, the lignite fuel size is minus 10 mm. So there is no pulverizers. So it is simplified here, and it from the different stage of crushing, we have 3 stages of crushing for the fuel. Since we have our own captive mines, size is 1000 mm, then we bring it to 250 mm, from 250 mm to 50 mm, and then from 50 mm to 10 mm. So the 3 stage crushing is there, and then this 10 mm and below particle size is directly being fed to the combustor through the lignite filter and other feeding arrangement. There is no requirement of pulverizers, but for limestone, which is being added as additive, we need to have pulverizers. We have 3 pulverizers. That particle size is almost like the pulverizers being used in the normal conventional power plant, and 75 micron size limestone is being added with the lignite for capturing of sulfur inside the boiler. This boiler has an advantage of high sustainability under cyclic loading because of the maximum heat storage. High operational stability means even if fuel cut out is there for 10-15 minutes, we can support the operation because the refractory and the bed material which is there in the boiler, which stores heat for almost 15-20 minutes operation. In quick restart under hot box up condition, because there is a high heat storage inside the combustor, it helps. Then from yesterday and today, there is a lot of discussion on the flue gas desulfurization plant, FGD. That is the major advantage of this boiler. There is no FGD requirement because already we are complying with the new norms. Though these units are 20 years old, our phase 1 units are 20 years old. It has been commissioned in 2000, and phase 2 units are in commission in 2010. That is also around 10 years old. But we are complying fully with the environmental requirements with reference to the SOx, NOx, even particulate emission also. That will come in the next slides. Though there are these advantages, there is other disadvantage also with this CFBC boiler. When we have decided to go for CFBC technology and not PF boiler, there is a huge cost to the company. Because of tonnage, you see 125 megawatt boiler itself is 12,500 ton total boiler tonnage is there. In that, 1,500 metric ton is refractory itself in each boiler. And this refractory, though had advantage with the operational side, on maintenance side we had a great disadvantage and creating a lot of challenges for us. Because when there is a outage, a higher unit outage owing to duration, owing to huge refractory. When there is a outage, or whether it is a planned outage and force outage. In case of force outage, almost 24 to 36 hours is lost only in the cooling of the boiler with the improvised operational practice. Otherwise, earlier it used to take more than 72 hours. Even if there are some issues in the cyclone or backpass side, which is high temperature zone area, the outage time will be say 60 to 70 hours without doing any work. And then only you can start the maintenance activity. So this is a major disadvantage. Even during plant shutdown or AOH work, it takes almost 2 days cooling for this. And then at the last of doing all this, then if you are doing refractory applications and refractory repair work, which is a major part of the AOH work, it takes almost 3 days, 72 hours for refractory dry out. So virtually we are losing 5 to 6 days in the process side. And then only we will be able to start our maintenance activities. The major disadvantage of this technology is higher auxiliary consumptions. Instead of for this size of PF boiler 10%, the auxiliary consumption is 12 to 13%. Earlier we are achieving in 11.5% range when we had a good fuel and lower moisture. Now it is almost 13.25 and 12.5. So range is there. So this on account of auxiliary consumptions, we are losing our generation 3% and not able to export the grid. So this is our internal consumption. Then because of this refractory and the higher tonnage and the configuration and arrangement of the major pressure parts, there is a major issue regarding approach and access for carrying out the maintenance activity. So which further extended our outage time, and there are a lot of criticality in doing the maintenance. This boiler, we are using the bed material, which is nothing but our bed ash, which have the erosion property. So once it circulates in the boiler or slides on the wall of the combustor, it's cause a heavy erosion, and that is a major reason for outage of boilers. For that, we have taken different measures. Certain area refractory have been provided for the transient zone. Then we are using the metal spray coating in the high erosion prone area. Regarding this compliance of new environmental norms, basically we are complying with the new environmental norms, but we have to do a lot of work in the ESP. That has already, we have done almost 50% job and balance is going, but we are meeting the requirements. But for that purpose, we are on daily basis monitoring this on SPCB and our GPCB, in our case, Gujarat Pollution Control Board, and Central Pollution Control Board on daily basis, and it is on 24/7 basis. Continuous monitoring of environmental parameters, and if there is some deviations or some issues like shutdown of units or ESP pass maintenance work, or in the monsoon there fitting issues in lignite and lime, we immediately respond to the concerned pollution control boards with the reason for deviations and actions taken. Then on daily basis we are monitoring this, all these SOx, NOx, SPM parameters and taking corrective answer. For this, achieving this, we have to maintain our boiler operating parameters also, so which should support the emissions. So that is also being done on regular basis and continuous basis. Then, as already explained, this NOx emission were being maintained because of low combustion temperature zone. So it is always the boiler combustor temperature is almost in 750 to 800, 850. And this supports the reduction in the NOx. So this is the very important and critical parameter for us and being monitored regularly by the operation peoples. And on the parameter sides also through the online SPC, GPCB and CPCB websites. SOx norms, we are feeding limestone. Limestones, we have our own captive mines limestones, but quality is not good, because yesterday and today also I had seen lot of discussion when on FGD plant there is a major requirement of quality of limestones. Our limestone is a very poor quality with a CO content around 41%, 42%. Even sometimes we go below 40% also, in the range of 37%, 35%. So this is creating another process, because once its quality goes down, then feeding will be more and then reactivity will be also less. So this creates a lot of problem. Refurbishment of existing ESP fields, we have in all the 4 units almost 60 ESP fields. We have almost done retrofitting of almost 50%, 30 ESP field, and balance is in process. In the design itself, we have kept the provision for dummy fields in both phase 1 and phase 2. Phase 1 there are 7 in the last, but in phase 2 in the first field itself is a dummy field. So we have revived that dummy field. This has helped in compliance with the particulate emission. The design of our this phase 1, this 2 into 125, that is 250 megawatt, is 100, which were commissioned in 2000, 100 mg per NMQ. Now this design is 150. The new requirement of environmental norms is 100 mg NMQ. Similarly, for phase 2, which were commissioned in 2010, design in 100 mg NMQ, but the requirement now with the new norms is 50 mg NMQ. So this is a major challenge for compliance. But how is the condition now? So just I would like to present this, what we have discussed. The environmental norms for our phase 1 units, unit 1 and 2 is 100 mg. Against that, we are generally within the limit and varying from 70 to 90 normally. This could be possible by restoration of all the ESP fields, and dummy field is still left out. We are planning to that restoration of dummy field, so we will be always fully complying with the requirements. Regarding this you can see all participants. There is a requirement of 600 mg NMQ, but our emission is less than 100 mg NMQ because of addition of limestone as additive, which reacts with the sulfur. Sulfur content in the lignite is almost 0.5 to 1%, though it is designed up to 2%. So, and it reacts with the sulfur, forms CaO reacts with the sulfur and forms CaSO4, which is gypsum, and that is like a sand. It is coming out from our combustor itself and being used for different filling material, manufacturing of bricks with fly ash. It is just like a substitute of sand. So here the compliance is, if you can see, that from 1600 requirement, we are even with 20 years old in it, we are achieving less than 100 mg NMQ. And NOx side, though requirement is 600, we are achieving less than 40 mg. So this is the beauty of this CFBC technology and the process requirements for achieving this environmental compliance. This mercury requirement is not applicable to this because this boiler was commissioned in 2000. Similarly, in our SLPP phase 2, SLPP Surat Lignite Power Plant phase 2, the particulate new norms requirement is 50 mg NMQ. We are achieving almost 40 to 60. We are restoring our dummy fields, so we'll be able to achieve this within the rim and restoring other capsules. So already we are complying with that also. I will show you the CPCB side details data also. Similarly, for the SOx, though it is 600, we are achieving 120, and the NOx also. Earlier it was 300, now it has been revised. It has been discussed, I think, during seminar also. Okay, 450 mg NMQ, the new norms. So we are achieving almost 1/10, less than this 40 mg per NMQ. And mercury side also, it is in compliance with the requirements. Apart from this, the third one is the water side. Water side also the requirement is 3.5, and we are achieving less than 3 because of recovery and reuse of water, almost 15 to 20%. So various blowdowns and the other process sites, lignite runoff pond, guard ponds, all ETP plant, and this. So this way we are utilizing, and this had helped in water consumption. You can see this screenshot from CPCB web page. What I can show the data, the SOx is 59.11. It is for complete financial year average. And then the stack emission is 84.08. The limit is 100 here. Here it is 600. And the for NOx also you can see 21.61 mg. This is for unit 1. Similarly, for unit 2 also it is in the same range. Unit 3 also you can see it is almost complying with the requirement. With the SOx almost 118 against the 600. Then the SPM is 55. Then the NOx is 32.89 mg per NMQ. These are all the screenshot of CPCB web page. This is for boiler 4 also. The SOx is 117, the emission is 66.87, and the NOx is 24.68 mg per NMQ. So this is being monitored by CPCB on regular basis. We are communicating with them. This is the average what I have shown for the last financial year, and we are very much within the requirements. But I would like to come to the major issues and challenges with this. Apart from this ash utilization side also, the Surat Lignite Power Plant from 2004 itself, we are achieving 100% fly ash utilization, and we have received the National Fly Ash Utilization Award in 2005, and further from 2016 to 2020, consecutive 5 years we achieved from the Fly Ash Utilization Award from Mission Energy also. The ash generation is almost in the range of 5 lakh to 6 lakhs 6 lakhs tons, and ash utilization is basically on the mainly on the fly ash brick by the ancillary units in the surrounding area, almost 50%, and the road and paving blocks almost 50%. So it is being used as a job opportunity for the local community people and for business development also, because this is, and in the even in the plant also, in the expansion project we have used 100% fly ash bricks in the plant and colony. So this has given the confidence to the local community and people for usage, and it is being used extensively. This year, of course, because of lockdown and pandemic, we could not utilize so much because of the issues known to everyone. This, you can see the silos of the plants where we are using this for taking out the ash, and the telescopic tube to avoid dust nuisance. So 100% utilization is there. Even waste utilization in canteen product, biodegradable wastes from industrial canteens, guest houses and kitchens are being used for generation of this vermicompost. So this is being used for the gardening and the other plant requirement for the and agriculture requirements. So now I would like to highlight the major issues now and challenges. Though we are complying with the requirements of the new environmental norm, there has been a major issues on the operation sides, cost sides, unit availability side, outage, efficiency, auxiliary consumptions, boiler operator loadings. So these are the very maximum of plant availability and operating factors which are affecting and costing us very high. See, regarding quality of lignite, already I told you this GCB, because it is a natural product, GCB has gone down because of the variations in the mining fuel available. Apart from that, GCB has gone down from say 3000 to almost 2500, so it is almost 25% variations. Similarly, moisture content, you see, it is earlier we are getting 40, 43%, 52%. This moisture has a serious impact on the corrosion side, because this lignite which we are using is having sulfur. Apart from sulfur, it is having chloride also in the range of 0.33 to 0.3%. So this sulfur and chloride forms the acid, H2SO4 and HCl, which corroded badly the ESP casings and the ESP components also, like collecting plate and other things, which ultimately affects the total operations. Because of this high moisture, it creates problem of fire evacuation also. So this is a major challenge for us, because we are facing a lot of air ingress issue, because though we are replacing it on continuous basis, but corrosion rate is very high. We are in touch with the Corrosion Research Institute of Chennai, CSIR laboratory, and interacting with them and other known fact. I would like to get feedback from the participants also, if anybody has regarding this, because this is a major challenge we are facing in operations of the plants. There is a huge, I will show some photographs which will clearly explain the things, but this causes huge ingress and which affect the operations also and the ASP performance. Apart from this, for compliance with the new environmental norms, it is to be around 7 to 10%. We have to dose this limestone of the fuel, and fuel is almost, it is almost 125 to 140 ton. Earlier we used to 100 ton per hour. So this consumption of limestone with lignite causes boiler lower downing the boiler efficiency almost in the range of 1%. If you fire almost 10 TPH per hour limestone, it reduces the boiler efficiency almost around 1%. And the auxiliary consumption, because of this moisture and high fuel requirement and limestones and other rotary equipment of limestones like mills and the blowers, goes almost, instead of 11%, it goes almost 12.9 to 13.25 or 13.13, above, just above 13%. which is a major area of concern for us. This then limestones, what we are heating, it affects the boiler loading also, and then we are getting lesser output. And not only that, these limestone powders get deposited and hardened in the bypass, superheater and reheater tubes. So this affects the heat transfer and overall the boiler performance and efficiency. For the limestone heating, since the consumption has increased because of lime quality and continuous and the new norms for SOx, so this causes the lot of fuel utilization, HFO. So that is also a cost to the company. Then whenever we have to take the ESP maintenance work, you have to do the partial loading. This causes also huge to the overall plant availability and plant load factor. Then in the plant outage, for refurbishment of the fields and the restoration of damaged fields, we need almost 30 to 40 days. So that for that period, durations, apart from not only 40 days, sometimes we have to go for another 2-3 months so that we can comply with the SPM requirements. So then we have to run the unit on part load with one ESP pass. So this is a huge cost. Of course, with the measurement of SOx, we try to optimize the limestone consumption, but because of limestone quality and reactivity, it is in the range of 7-10% and causing affecting the boiler performance. The South Gujarat, there is an issue of high relative humidity of ambient air and high rainfall, particularly during monsoon. So there is a lot of issue of the feeding, and this always affect the performance, environmental performance like SOx and this. Apart from this operational performance and parameters, there is a high capex and opex requirement because of this auxiliary consumption and the cost involved in restoration of dummy fields, making shades for the limestones, lignite to feed in the dry during this to comply with the norms. So these are the, and operation side also the ESP maintenance, ESP services, and a lot of drives, and then the restoration of dummy fields. So this cost to the company. These are the major challenges we are facing, and I would like to take feedback or views from the participants on the major issues. I will show some photographs also, so that will give clear picture. In the past, we have faced some problem in the SOx analyzer that has been changed with the PermaPure dryers, and this has been quite effective, and there is no issue now, and it gives a better result. I will just show some slides or photographs, and then I will conclude my presentation. These are the boilers and then the ESP, just a vivid view of the plant. This is the ESP phase 1. We have the 7 fields, and the 7 fields, last one is the dummy field, which we have to restore. But we are meeting with the new environmental norms. See, this is the issue of the corrosion because of the moisture and sulfur and chloride. And it causes total damage of the ESP casing. Though if you replace within 1 year, 2 years, you face the major problem. And this causes air ingress in the performance of ESP and the issues of compliance of the norms. Sometimes then you have to take the maintenance, then unit availability will be go down. So these are the issues. You see these photographs also of ESP side casing, and this is mainly because of the corrosion. This is a major challenge for us to arrest this air ingress and improve the performance of the plant as well as units as well as the environmental requirements, particularly ESP and SOx. See, even the damaging of the, because of the sulfur, chloride and moisture, damaging of the collecting plates of the ESP. These are also the some photographs which clearly highlights the corrosion inside the collecting plates. ESP outlet also. So these are the just, I have a glimpse, see the corrosions of that. Then APS tube also, because of this chloride and the lower, this cold in corrosion is there, which I would like to share some awards and recognition what we have received in the past, mainly on the environmental side. From the South Gujarat Chamber Commerce, we received the environmental this. Then the Mission Energy also, we have received the Environmental Excellence Awards. Then fly acetylization, and then from Center for Science and Environment, we got the Best in Water Use Awards. From Ministry, we got the fly acetylization awards. I will show some, this is the, you can see the green view of the power plant and the surroundings. So this is the beauty of the CFBC technology. We are not polluting at all the nearby surroundings and environment and complying with this. Even though you can see that this is the greenery in the plant itself. These are some photos of the green belt area in the plant and surroundings and mines area, overburden area. And the Central Electricity Authority team has visited in 2008, and they have given the letter, appreciation letter, that the dense green environment created and maintained by this plant and facilities is unique. The ambience inside the power plant premises maintained in very good condition with low noise level and external. This is just appreciation from Central Electricity Authority and Ministry of Power, which will encourage us to give more focus on the environment. And during monsoon, we cover this, the total lignite from the, to have the better performance. Thank you very much. I would conclude, and thank you once again, Mission Energy, for giving this opportunity.
It was our pleasure to have you, sir, and it was our pleasure that we get an opportunity to honor you for various initiatives which you have done. I would now request Mr. Bhargava to share his presentation, and we will take the questions from the audience once Mr. Bhargava finishes his presentation.
Good afternoon, everyone. I'll share my screen now. Just 1 minute. Good afternoon, everyone. I would like to introduce a Dornier group of companies which are in energy and infrastructure engineering and consulting. And especially, we have been working on emission control systems for the last 50 years, being in Germany, handling difficult coal, and in Eastern Europe, which is primarily not only lignite, but also having 10 to 12% sulfur. So this is where we come from. A Dornier group consists of 6 companies: VPC, which is the primarily for energy and environment. We do engineering, construction management, program management, design, and operation and maintenance of power plants. Then we have Dornier Consulting International, which is for infrastructure consulting, whether it's mobility or aviation, transport, e-mobility, and all these new features in the technology. Then we have Encotech, which is a 50-50 joint venture in India. We do power plant operation and maintenance. Then we have Suntrace, which is a solar consulting company specialized in solar, and is very few ones in the world which has completed large-scale floating solar projects, completed projects. Convico is a construction company which primarily focus only in Germany and Eastern Europe. And then we have VND, which is for nuclear dismantling group, which is working in Germany and Europe. We are in Asia and Africa and Europe. Primarily, we are not in Americas and South and North America, but we primarily focus in these countries. We have an office in Delhi. We have around 1,500 staff. Regarding the main focus, which is the VPC. VPC started 55 years ago, and it has been through various utility company, which you have heard about, VIAG and Vattenfall. So all these companies, engineering, consulting, and labs, material labs, were combined together and was acquired by a private equity company in 2014. And then we integrated many other features to become a member of the Dornier Group, which is roughly 70 million euro engineering company. So VPC is in project management, plant engineering and optimization, process engineering, electrical and INC system, O&M, and environment. So we have a full view from design to concept to commissioning and O&M across all the verticals of fuels we are handling, whether it's solar or hydro or introduction to battery system. We are just implementing one of the largest in Europe, 50 megawatt hour battery storage system. So similarly in emission controls, which is a current topic, and thanks to Mission Energy, we are getting this opportunity to present to you. So as far as technical specialized services, we do even rehabilitation, modernization, and life extension projects. We're currently doing in Ghana. We're also advising on energy improvement, energy efficiency improvement in waste incineration plant. These are all current projects last year, which has happened, or ongoing projects. We are also developed the latest battery storage system for hybrid applications for VIAG, which was a utility company where we implemented to their utility company which is coal-fired power plant with solar, wind, and battery. And then we also are advising several countries on EV infrastructure rollout together with the distribution companies, because this goes very well with the distribution companies, and this is what we have been implementing. On thermal generations, so we normally work with World Bank, KFW, IRDB on electricity sector, power sector advisory for the government. Plus, we also design and operate grids. And of course, the main feature is the coal-fired power plant and nuclear power plant, which we have been designing and operating for over 55 years in several countries, which I have just given some examples. And these are the current projects in Azerbaijan, in UK, in Germany. Even in transmission distribution, we get involved in planning of the transmission network for a country or a state. So we've done for Ukraine. We're currently doing in Ukraine and UK. We have done for Vattenfall, one of the biggest utilities, for modeling the entire network. These are multi-year contracts in which we advise on renewable energy integration. We advise on flexible operations. How does it affect these? So all these services we offer in various countries, including the distribution, where we are making them ready with VRE integration and e-mobility, which is coming very fast. On the emission controls, and today's agenda is what are the possible issues and challenges which will come during execution. So based on our experience of our specialists and our experience in India, especially on two projects. One was with Jindal Power Limited, which we helped them to design the complete tender specifications and something more in which, if they want, they can implement or fabricate equipment within their fabrication facilities. So defining operation parameters during design phase, we feel, is the most important factor and most challenging, because CA has issued only the guidelines. So it is not saying that how do you want to operate. So plant operation range also affects the total number of budget or how much money you're going to spend in doing it. So this is to be defined as narrow as possible. Plus minus 20% range is much more beneficial, because that's how the whole plant will be tuned effectively. Correct measurement of existing emission is a must, which is always required, because emission compliance is 0 and 1. Either you're compliant, you're not. So it's a very different ballgame when we go for testing of the plants and commercial operation date and redefining all these parameters. So baseline for plant emission, auxiliary load, heat rate, and different part loads is essential as per our experience of specialists. So based on these different data and curves is where we design the whole process of SOx emission. Availability of limestone, long-term contract, and correct quality, which is also mentioned by our friend from Gujarat, that limestone quality differs maybe from 87% to 97%. But that's a very big difference, which we should not be taking approximation, because you're extra putting 30-40% cost to handle that. So this is very critical. Optimize SOx and NOx together. It's not independent, because they have to be tuned together with the implementation of even operational flexibility, which now you have to turn down the power plant to 25-30% load without using oil firing. So all these parameters need to be optimized together. So we always call FGD or operational flexibility or plant performance improvement. All these are engineering solutions. These are design solutions. it's not there is one fit to all. If you have a FGD tower or equipment or absorber, it cannot fit for all. So this is what the whole point is. Handling of mercury is also, we have a very large experience. And during this, if we have to handle mercury in any of our power plants, especially captive power plants, or where you have the coal coming from, imported coal is coming, then we have to worry about handling of mercury. Then for CSERC review of technical regulatory compliance, it's very essential that a good engineering company defines those parameters accordingly, which can be funded effectively. So it shortens the time when you have a lead consultant who has done it before for years together, so which will help you to shorten the time in implementation. And there has to be a separate discussion on CFBC boilers, because the other boilers is what we are talking about. CFBC boilers is a different ball game, which I think our friend from Gujarat has done it. An experienced engineering company can provide component specification, manufacturing design for India-based manufacturing also. So since we have to do 160 or 170,000 megawatt, we have only ordered only 1/3 of it. So we have to order another 100,000, say. So a lot of companies can step up, the fabrication companies, the construction companies can come up and start making these equipments, which we can help and sharing a technology transfer agreement. Performance testing guideline as a power plant unit first for all the parameters is essential. And then if it fails, then we go for individual component testing, not individual component testing and adding all the tolerances and inefficiencies and put together on a test data. So we would recommend to do it other way around. Training of operators is essential, warranty services and availability of spares in India. So these are some of possible challenges and issues which we see the industry will face. We have only one unit commissioned by NTPC and operational data has yet to come. So definitely these things which we share will be very important. We supply from VPC, is one of the group companies of Dornier, which has capability of being an owner's engineer from concept commissioning to O&M. We also ensure that we have available experts. Whatever references we are giving, we still have those experts within the company who can help you, because you may have a reference, but you may not have the same experts which have designed this or commissioned those plants, but we have it. So we do entire plant engineering. We do right from providing the specification, main equipment, optimizing SOx together with NOx compliance. I mean, this is what we need to do by optimizing auxiliary consumption. Just doing SOx may not give you optimized plant. You have to do it together, including operational flexibility. And even during construction, we have to be very particular in terms of, because we have to reduce the shutdown period and everything. So planning of what we have done together is very essential, which we can share with you, all these experiences. Some of the key references which we have 2 into 827 megawatt move work, where we have done every possible upgrades, right from FGD compliance. If you see, the figures are NOx 70, SO to SOx is 100 and CO 100, and even the particulate emission is very, very little. And here, entire things which you are talking about, performance improvement, operational flexibility in terms of FGD upgrade in the emission control system. So all this is available, and we have all the staff which design and build these plants are still available with us. Second plant is Boxberg. It's a supercritical with a bituminous coal, and similar data we have for Boxberg plant, which we have done it. So all these experts and the plants are readily available, which is upgraded for all these facilities. Currently, we are executing 4 units of 344 megawatt in Elbistan. And this is what we are doing. We are doing from, giving the solution of complete unit-based engineering and multiplying it to make it uniform, component selections and everything. This is what we are trying to do. Another important factor is the mercury reduction, which we have very large experience in, which we can help assets and utilities to also, if there is any mercury requirement of control. So this is just explaining what we have done in Germany. We have done in multiple countries and multiple plants for the entire country, including testing, dosing, and making the mercury compliance. So in general, we can do most of the engineering and consulting. We support investors and asset owners in due diligence. We have more than 100 trained operators within us, which we deploy them. We are independent and neutral to any OEMs. So this is what I wanted to share. In India-based services, we have Dornier Group India as a group company, and we also have Encotech as our O&M company. So we can do all these performance enhancement, flexible operations, emission controls, O&M, and we have started participating in local tenders with state government, and now we will be doing it for private sector customers very soon. We also have a complete O&M service company where we are involved in 14 projects currently with 1,200 staff. This is just a nutshell of what we do, and we are there in all these projects within the country. We have an India-wide presence, so we can quickly go and help our customers in any of the features, especially on emission compliance. Thank you. Thank you, Mr. Khatri.
Thank you for the crisp note and very insightful presentation on the Dornier Group's area, which I'm sure the participants would like to contact you soon. Now let's proceed with the first question by Mr. Vishnu GVN from the maintenance from the CLP India. Am I handing the mic to him?
Good morning, sir.
Good morning, Vishnu.
Sir, my question is to Mr. N.K. Singh, sir. A very good presentation, and we felt very happy looking at the CFBC boiler and the requirement that there is no requirement of FGD in that plant. But sir, I am from maintenance, so what is the percentage, gypsum purity percentage that you are getting from the gypsum that you are getting from your plant, and whether it is being offtake by the customers, like different vendors?
See, could I reply now?
Yes, please.
How much percentage purity of gypsum, sir, that is being that you are getting?
See, this may be very low quality because the CAO itself in our limestone is below 40% and around 41%. And this offtake is the outcome. It is because it is mixing with the ash. So it is bed ash, which is just like a sand. Our particle size is 1 mm to 1 mm. So this is being used as a sand for the making the bricks. So there is no other offtake used for this. And purity, because limestone purity itself is below 41%. So gypsum purity, because there is no separate gypsum, it is becoming as ash plus lime.
Yes. So we are also operating FGD, sir, for the last couple of years, but we are getting like purity is 90%, more than 90%.
Purity will be definitely below 40-45%, not 90%.
Okay. And one more thing, sir, regarding the limestone handling system, what kind of mills that you are using, sir? Because we are also struggling with the maintenance, like mill liners are getting damaged. Ours is an overflow ball type mill.
Okay. Okay. Right. Please continue.
So I just want to know, like, what is the type of the mill, and what about the liners of the mill, and how are you maintaining it?
Mills are supplied from FL Smith. That is the Denmark company.
Yes, sir.
They have the office in Chennai. This is tube and ball mills.
Yes.
Provided with hot air generators.
Yes.
We don't have major issue of liners.
Okay, I hope it is a dry lime, right, sir? It is a dry lime. It is a dry lime feeding, right? It's not a wet.
No, dry lime. Lime is being fed, not wet. Normal lime, and then it is being dried through the hot air. So it is dried lime is being fed to the mill. Hot air temperature itself is more than the mixture temperature is almost 100 degrees. So it's hitting, almost moisture is being removed.
Okay. Maybe that whatever the mill that we are maintaining, it is a wet lime mill, sir. So we are struggling with
ours is a dry lime mill.
Yes, we are struggling with the maintenance issues. However, we are going for indigenization.
Maintenance issues are there for us also, but not severe maintenance issues. Like the valves, liner we also replaced. Hot air generators also we find some difficulties. Then the output of the class fan is to be maintained. That is, there is an issue. Otherwise, there is no major issue. My capacity is almost 30-35 ton, and we are conveying almost more than 500 to 800 meters through the pneumatic conveying from the milling plant to the boiler.
Yes, sir.
So it has to be dry, otherwise it will not be possible to convey it.
Okay, sir. Okay, thank you, sir.
Okay, most welcome.
Sir, a very out of the way question.
Yes.
You are in a city called Gujarat and Surat.
Right.
The city is called the city of food.
Mm-hmm.
I am a lover of food. I am just wondering, how are you managing the pandemic times without having food from outside?
Really, this is a very difficult time. We are almost 50 kilometers away from Surat. So we used to go Surat always to enjoy the food, but somehow during this pandemic, we are totally locked.
Yeah.
We have to manage the plant operations. There had been some cases and issues also. So we have to, Surat is affected also. Surat is affected largely. So, but we have to pass this time, and we hope you will come out right now.
Right. Let me see few questions, or nobody is probably raising the hands. Then we might give a break for the food, and then we will continue the next sessions. Participants, kindly raise your hands as soon as possible if you have any questions for Mr. N.K. Singh or Mr. Bhargava. If not, in few minutes I will take a break, and then we will join the session post lunch. There's one chat which is popped in. So, what is the absorption efficiency of typical Indian limestone?
In our case, CFBC, it is more than 94%, 94 to 95%.
Then what about the other side, the FGD side, Bhargavaji?
It varies because it depends on the quality. So, but it will be the range of 92 to 96%.
We
maybe 95.
We don't have limestone. That's again a problem. And over and above, we say that varies on the quality.
Yes.
पहले तो limestone ही नहीं है, फिर quality वाला limestone कहाँ से लाएं?
Yes, and that's why when you do design, we have to see where the limestone is coming, how the mine cutting is done, what do we ensure, what's the variability. It is similar to the problem we had. We have built power station without having analysis on the coal, how it is going to come. And then we keep on upgrading and optimizing the power plant. So when we design the power plant at, say, suppose 3,200 heat rate or 3,000, kilocalories. So coal will come at 2,600 and the design is 3,600. So from the very beginning, the plant is not designed. So I think Mr. N.K. Singh is very made it very clear that all these limestone qualities hugely depending on this. You can't have a design, which I said, operational parameter and design. You can't have a variance of 10 to 15%. It's like putting extra 30-40% cost. So, the experience of Mr. N.K. Singh, also operational experience, we don't have much, but he's right in saying that the quality of limestone is very critical for the success.
Similar way that we got habited with cities. We started living into the cities, not thinking of planning the cities. And now when we talk about smart cities, we cannot leave a city like Bombay and think of going to a smart city in Nagpur and start living there.
I will just further add, apart from the limestone quality, there will be the temperature regime, means operating regimes, and then we call molar ratio, CA/S, calcium by sulfur, due to and reactivity at that temperature. These three factors allow you what will be the absorption rate.
Okay.
Apart from the quality of lime, these two factors will also affect the absorption of sulfur.
Reading out another question in the chat given by Prabhat Katiyar. on what basis a normative parameter from limestone consumption is being decided when we are not sure about the consumption?
No, it is very much sure because we have given our actual operating data to CRC and GRC, and based on that has been audited data and by the third party, and based on that they have allowed the normative rate.
Okay.
It is based on the actual consumptions and the industry norms and international industries norms also, but it is based on our plant performance, and benchmarking has been done on that line by the CRC, Central Electricity Regulatory Commission, and CA also, Central Electricity Authority.
I think his question is for the normal FGD plant. That's what he mentions.
Okay.
Yeah. So as also extension of Mr. Singh has said, it depends on the design, and those design parameter is based on the limestone quality. So the normative is a range in which the CACRC will say for this plant or this type of plant, what is the average data, and which this is what is going to be cleared.
Okay. There's a question popping up. It has been discussed that gypsum from poor quality of limestone cannot be used in current industry. Is there any other use of this gypsum except landfilling?
Yes, we can make gypsum boards, and there are technologies available which we can use gypsum board very widely, but it is not yet started. So there is application, but somebody has to do the study how much people will start using gypsum boards. But it's very viable.
Yeah, it is viable, and people should start using gypsum board instead of the regular wooden boards which we use. I know the scientist from one of the CSR has built boards from ash, and the technology was also transferred. There was somebody in Chandrapur area who is manufacturing those boards, and I personally have used those boards for doors of my home.
And there are some old plants available in Europe which can be shifted if somebody wants. So that was used to be when we started doing it, if you remember, in 2016. So many European old companies which have shut down coal-fired, they used to always have coal-fired power plant and a gypsum manufacturing unit. So those can be relocated at a reasonable cost.
Very well, very well. So thank you with the last question, and we'll see you again after lunch. Thank you so much.
Okay.